Hi guys, and welcome to another lesson where we are going to use or show you some examples on how to use Python across the wire. So you can do many different tasks across a network connection, whether that connection is the public internet, a local area network, or a private network. You can process data, serve web pages, and even run Python scripts remotely. So this section introduces a few of the simple different ways you can run Python across a wire. So just note that none of these examples are production-ready code, but this should be a good way to get you familiar with the different powers Python can provide. The first thing we are going to talk about is the XMLRPC, which stands for XML Remote Procedure Call. And this is an older technology that is still used in a few legacy systems. This is how data was once processed across the internet using XML. We now use JSON to pass data back and forth. However, some systems still use XML and require remote procedural calls. And because of this, Python has a built-in XML RPC module. So we're going to make one and watch it in action. And what we are going to see is we'll set up in just a few lines of code an XMLRPC server that will run locally in one terminal and serve up a single simple Python script which we'll create, and we'll then open another terminal window and run the code remotely. And after that, we are going to talk about the socket servers, which is another way of communicating over the network. But first, let's demonstrate how we can serve files in our local directory via an XMLRPC server. So let's open up a command prompt session or terminal window. And so you can start Python. We don't need to be in the correct folder or anywhere right now. So let's import the XMLRPC server object, .server object from the simple XMLRPC server module. And similar to the HTTP code from the earlier lesson, we have to create a server object. We also want to create some sort of system feedback that will tell you that our code is working. Use the port 8080. So set up your server with the code we will be running, and in this case it's just a simple function that will square a number that is passed in. For some reason, I think this will work on Unix. This print message it's not returning in Windows for some reason. I'm not sure why. So next we're going to register our function so that it can be used by the client code that we'll be creating in just a moment. So we should have gotten a print message back that we are serving on port 8080. For some reason it does not reply with that. So now I think it will work on Linux. So start another instance of the terminal or command prompt. And then we import, then we have to start Python here as well, and import the XMLRPC client library. So if you happen to read any of the documentation on the http.server library, you probably discovered that there is an HTTP client library as well, which will allow us to access URLs via client. The XMLRPC library is set up in much the same way. So now we want to set up a server proxy object. Typos. And finally, we want to call our remote procedure, or the Python function that is sitting on the server in the other terminal window, which is here. Let's try to make it viewable, and for some reason it just everything went black. So now we're going to again call our remote procedure, that is the Python function that's sitting on the server on the other terminal window, which I just had to restart for some reason. So you also notice something happened in the other window, and we got this, the square root of 3 is 9 from the server. And so when we look in our server terminal window, we should see that the server received a request and returned via status of 200. So to stop the server, you just hit Ctrl+C. So this should stop the server and open that port back up for use. So we just show how to set up an XMLRPC server and then XMLRPC client and have them talk to one another. This is the power of Python in action. Both of these modules are built into Python and are available for use out of the box. So that was just a simple XMLR example. Next we are going to talk about socket servers. So many people ask just what we could use such functionality for in the real world. XML processing was once the way we process data across the wire. Some organizations still use this method. However, the power that we wanted to illustrate was that you can even set up Python to run remotely. So if you had a large data file and wanted to process it remotely, you could set up code on a remote server and then call the code from another machine. Next, we'll look at some other examples that can also accomplish these tasks, and that is with socket servers. So if you ever heard anyone talk about WebSockets or streaming data, they're usually talking about TCP and socket servers. These servers utilize TCP or Transmission Control Protocol. You may have heard of TCP/IP, which is the same thing. Python, of course, has some built-in libraries that can enable you to create TCP sockets to send and receive data between 2 points using the Internet Protocol. So we are going to try something out here, that is to get a bit more involved with some Python and do some things in a more Pythonic way. We're going again to set up a server and a client, so we'll need 2 terminal windows again running to complete this task. However, we'll be also creating a class to handle our TCP request to illustrate the use of classes in Python. So again, I'll just restart the terminals to just clear everything out. And for this exercise, we'll be using the IDE to write some code. So to set up a server via Python for using TCP to send and receive data directly from one machine to another over internet, let's create a server file, server.py, in our IDE, and import socket server. And then we need to set up our class for the request handler. This class is going to be instantiated once per connection, and each time you will want the handle method to be overridden so that we can communicate with the client. I'll explain in a minute what's going on here. And the next line is to just send back the same data but with uppercase. So self is the instance of the TCP handler class, which this is the TCP socket that is connected to the client, and this will make more sense when we write the client code. So here we are taking the request that is being sent over from the client, stripping it and saving it to the data property on the instance, which is self.data. We then are calling some illustrative print statements so that we can see things as they happen. And finally, we are sending the data back to the client, but transforming the string into all uppercase characters so that we can see a change has happened. So now we'll do something familiar. We check to see if we're running as main. If so, we want to set the host and port variables to let the code know what host and port we want to listen to for connections. And finally, we'll do something that we've done each time. We'll set up a new server, create a server object that will allow our client to connect, and then we serve it forever. One more. Typos there. So just save the file. And now let's create another Python file which we call the client.py and import the proper libraries. And now we need to define the host and port we'll be connecting to. Remember, the server.py code is listening on this port, on this host and port for incoming connections. And the next is that we create some data that we can send over to the server. We'll use sys.arg to parse the arguments we'll be passing in. This will be our data. So, and then we need to set up our socket. The socket.sock_stream is simply the type of socket TCP that we'll be connecting through. And then we can use a try finally to try and connect. Get the right indentation. Then we have the finally block. So what's happening here is that we are trying to connect to the server and send our data. We are then storing the received data into the received variable. Finally, no matter what happens, success or failure of gaining a connection and sending or receiving data, we are closing our socket. This is just to illustrate the use of the module. Let's print out some results of our connection. So we'll save the code here as well. And we need to run this code from our command prompt. We can also do it here in the terminal. Sometimes this terminal here is not let's see if it works from this. So let's try to write our code here from terminal. So in the server there is no port. Just a typo. Let's try to start the server now. Okay, it's serving now, and now let's fire up the client module, and let's just pass in a string. So we can see that our server is very excited that we were able to connect. So what we did here, we created a TCP socket and connected to it via a client script, and then had each script send and receive data back and forth. And we saw that the server executed the string. So by setting up a server and telling it what host and port to listen to, we were able to create a client that would send data to that host at that port, and the two pieces were able to meet and send receive data successfully. So we've only shown you the very basics of what Python sockets can do. So the course object here is to familiarize you with all the tools that are available in the Python ecosphere. There may be times when a direct data connection is needed for updating data feeds in real time. This is where the power of sockets and streaming data comes in very handy. And luckily for us, Python makes this fairly easy. We recommend that if you're going to be creating network connections on a lower level, you understand the security risks and cautions that you will need to be aware of before undertaking such task. And we're going to mention some networking frameworks in the next lesson. So see you then.